Welcome. In this video, we're going to go through an introduction and some of the principles of low impact development. I have two versions of this in the notes. One is the filled out version, one is a blank version. If you want to write along with it, however you want to take notes. Subsequent notes won't be like this. It'll be more fill in little things here. This is much more wordy than the other ones, but I did want to get these definitions in front of you. So the definition of low impact site development, LID, low impact development, is a stormwater management strategy. So it sounds like a very general word. We're talking about stormwater. We're concerned with maintaining or restoring the natural hydrologic functioning of a site to achieve natural resources protection objectives and fulfill environmental regulation requirements. So you see the word natural in there a couple different places. So we're trying to make it more natural. And as I said in the very opening along the creek there, it really is the law in most places that we have to try as much as possible to make it natural. Some related terms, the low impact development term is still out there. You might hear green infrastructure or sustainable sites. Our goals are to match the pre-development hydrology. So at the end of these notes, there'll be another video where it goes through hydrographs, and you can fill that in. So we want to match the pre-development hydrograph, or a graph of the hydrology, how the water flows before it's developed. So some specific goals related to that is that detention ponds, it's a detention pond or retention pond. Detain, or stopping it for a while. Retain, you're holding it on for longer. I'll probably use them interchangeably, but if you want to be rigorous, there are different definitions. So detention ponds seek to reduce the peak rate of runoff to pre-development conditions. So while it's raining and the storm water is running off, we're collecting water in that detention pond so it doesn't run off our site really fast, and so we can let it out after the storm at a lower rate. So under low impact development, and again, this is the law in most places, we also have to reduce the runoff volume to pre-development conditions. So we can't let any more run in. With detention pond, you can let more run out, but you just don't run out as fast as it would if you didn't detain it. So you want to reduce runoff intensity and velocity, preserve riparian banks, stream banks, reduce sedimentation, reduce erosion overall. Preserve existing flow paths. So again, you try to match the nature. Water kind of goes where it wants to go, and we want to let it go where it wants to go. Preserve water quality. So all that erosion and stuff that comes through that degrades water quality. Reduce constituent loads. A load is a mass of something per time. Can be of sediment, can be of phosphorus, nitrogen. And so if you take the flow times the concentration, that's a mass per time of load. So we want to reduce those loads. There's a regulation program, a number, the total maximum daily load for impaired streams that we are required to not go over that. And so that dictates a lot what we do with stormwater. That's what dictates what happens in my yard, which is hundreds of miles. I don't know, hundreds of miles. It's way from the Chesapeake Bay, but the Chesapeake Bay total maximum daily load determines what I can do in my yard with the stormwater. I'll let it sit there for a few seconds longer if you're taking notes on it. Reduce runoff volume, reduce runoff intensity and velocity, preserve riparian banks and reduce sedimentation, preserve existing flow paths, preserve water quality, and reduce constituent loads. So how do we do that? Well, we preserve naturally vegetated areas and soils as much as we can. We grade to encourage sheet flow and to lengthen flow paths. So if you can get it flowing nice and flat over long areas, it's more likely to infiltrate and less likely to run off and less likely to create erosion problems. Disconnect impervious areas from the storm drain network. So rather than running it right into storm drain, can we run it over something first? So can we direct it over vegetated areas? Can we separate our impervious surfaces? Distribute small-scale, low-impact development technologies. So if we can separate them, that helps with the runoff, and also we can get credit for that. Provide filtration and infiltration of surface runoff. If we have volume requirements, which just about everybody does, you infiltrate that some way. You got to deal with it that way. Treat pollutant loads where generated or prevent generation. So some of these technologies that we'll go through are for water quality, and they can prevent the nutrients or sediments from going into the stream. Retention or detention storage to reduce peaks and volume. So that's always part of our stormwater management. Build various infiltration technologies. We'll go through a couple in this class of that. Reuse stored water. So rainwater reuse and collection can be an important strategy. And add natural vegetation. So those are all strategies we can use to reduce the runoff or improve water quality in our runoff. And again, I'll give you a few more seconds to write that if you're a writing person. I had a previous video of this where I typed it all up while you watched, and that was kind of awkward. So I just thought I'd show it to you this way. What are the 3 basic ways to reduce runoff? Infiltration, get it into the ground. Reuse it somehow in irrigation or something else. Evapotranspiration. So if it evaporates, it goes into the air. If it transpires to the plants, it goes to the air. So if it runs in a retention pond that's vegetated, you can get a lot of evapotranspiration and get rid of the water that way. So it's not running off. So you might have the thought that the old cities, you're kind of stuck with what you have there. And so the low impact development principles or the modern stormwater design principles are for new areas. But if you can go into an old city and retrofit it, you can help a lot with, for example, combined sewer overflows, where both the storm sewer and the sanitary sewer go in the same place. So if you can put some stormwater technologies in that reduce the water going to the stormwater going to the combined sewer overflow, can help a lot. Who or what is most impervious surface built for cars? We have roads and parking lots. It's designed for cars. Designing for a 2-year frequency will handle about 95% of all rainfall in most places. So our technologies are best management practices that we use. If we can design for a 2-year frequency, we're going to decrease runoff a lot. We're going to do a lot of good. We don't have to. We're not going to design our rain garden for a 100-year flood. Again, traditionally, site drainage is designed to remove water from the site, whereas LID seeks to retain water on the site. So it's been a shift over the years in thinking. So the problem with paving everything is we have more runoff, right? That's the problem we're trying to solve. How might increased impervious surface decrease the flow in a stream? Well, you do have more runoff quickly, but if it's not infiltrating into the ground, it's not going to go through the ground and then come out into the stream as groundwater. So we can actually reduce the base flow in a stream because we have less infiltration into the groundwater. Do LID strategies generally want to increase or decrease the time of concentration? So I'll say it briefly in the video I'm about to show after this on hydrographs, but we'll come back to it. Time of concentration is the time from when the last drop of water hits the site to the time it runs off. And we want it to spend more time on the site with more chance of infiltrating in the site. Just some terminology here that I've been throwing around. CSO is combined sewer overflow. MS4 is a municipal separate storm sewer system. Best management practices, BMPs. You'll hear that for stormwater. That can be used in other applications as well. Total maximum daily load I mentioned. And then NPDES is the National Pollutant Discharge Elimination System. So point sources like wastewater plants and stuff have to have NPDES permits, but we might also run into that with our stormwater. Now we'll move on to the hydrograph video, which I do at a whiteboard, but I would like you to do that one starting with the blank and fill it in as you go. The reason I have it twice is I erase the board and then I kind of focus on the latter part of it for the second one to emphasize the base flow. So that's the end of this video, and then we can start the hydrograph video.